Okay, Math 8 students, we are starting lesson 6.3, and that is comparing functions. So we're looking at various representations of those functions. We are starting with thinking about what we're looking at when we're comparing functions. We're looking at tables, we're looking at equations, we're looking at graphs, we're looking at descriptions, and we want to be able to compare functions that are in different formats. So a table to an equation, a graph to a description, all these good things. So what we're looking at when we're doing that is we want to look at rate of change, right? And rate of change is, if we're looking at a graph, that might be the slope, right? Which is our m. It might be our unit rate. And it's going to look at different for different things, right? Our Y-intercept, that's going to be, it could be our initial value. That's our b value in an equation. In a table, that's going to be when x is 0, y is b, right? So it's going to be those type of things. And shape of the graph, we're looking to see, is it a linear equation? Is it a positive slope? Is it a horizontal line? Is it a curve? So we're looking at the shape of the graph when we're comparing them to. We're also looking to see, is it proportional, right? Does it go through the origin? So those type of things. And so that's what we're doing as we go through and we compare functions. We're looking at those different types of things. So first thing we're going to look at here is we are going to be comparing an equation and a table. So let's go ahead and read the scenario here. We've got Quentin is choosing between buying books at the bookstore or buying online versions of books for his tablet. The cost y in dollars, so that's going to be our output, the cost of ordering books online for X books, so that's our input. Input is X, number of books. Y is output. And the equation is y equals 695x plus 150. So to interpret this, that means that it's 695 per book plus 150 probably for shipping or something. Or just an initial cost or a membership fee or something. So I guess it's online ordering, so that might be like a membership fee. The cost of buying books at the bookstore is shown in the table. Which method of buying books is more expensive if Quentin wants to buy 6 books? So this would be our input that we're going to be comparing. So we're looking at comparing the cost of 6 books, online versus bookstore. So what we want to do here is we want to go ahead and see if we can find an equation out of this, find our rate of change, find our initial value to see if we can then plug in our input of 6 books to see what the cost is going to be comparatively. So let's go ahead. We know that our ebooks, we've got an equation already. And your page is formatted just a little bit different, so you might be doing this off to the side. So our ebooks, the equation is y equals 695x plus 150, right? And we want to know what the output is going to be when x is 6 books. So let's go ahead and just figure that out. So I'm going to plug in my input of 6 books, my x value, to the equation and find out what my output is. So 695 times 6 is 4170. Plus 150, and that's maybe a membership fee or something like we said earlier. And so the total cost or output for 6 books when bought online is going to be 4320, and make sure you guys are using your units there. So we're going to compare that cost to the cost of books from the bookstore. So there's a couple ways that we can do this. We can find the pattern here with the table, or we can make an equation. If we're making an equation, we still need to find the rate of change in the table. So 1 book plus 1 plus 1 plus 1 plus 1. So that's the rate of change for x. So change in x is 1, positive 1. Then we're going to look at change in y. And that looks like it's plus 750 here. 15 to 225 is plus 750. 225 to $30, sorry, $22.50 to $30 is plus 750. So we've got a pattern emerging here. And plus 750. So our change in y is 750. Now remember, we do this for our rate of change. It's change in y over change in x. So we've got to flip it from our table, which means it's $7.50 per one book. Okay? So that's our m. That equals our m value. So if we've got y equals mx plus b, y equals 750 times x plus b. So the next thing we need to do is determine if there is a y-intercept, if it has an initial value, and so we just work backwards and find out what the value of y is when x is 0. When you have 0 books, do you have an initial cost? And based on this pattern here, we're going to subtract 750, and that gives us a 0 also. So this tells us that there is no initial value. When x is 0, y is 0. So the equation is then y equals 750x. So two things you can do. You can continue the pattern here and find out, okay, when x is 6, what is y going to be? You're just going to add 750. Or you can plug it into the equation, which is essentially the same thing. So 750 times 6 books equals $45. So in the bookstore, if he buys 6 books, it's going to cost him $45. So even though there is no initial value or initial fee, it still is going to cost him more because the books cost more per book. With this initial fee, this membership fee or whatever it is, the books cost less. So even with that, it's going to be cheaper for him to use the ebooks because $43.20 is cheaper than $45. So the ebooks are a better deal, which means, to answer the question, which method of buying books is more expensive? More expensive would be the bookstore. So bookstore is more expensive for 6 books. So that's comparing a table and equation. Let's go ahead and take a look at the next comparison we've got here. So in this next one, we're comparing a table and a graph. So the table and graph show how many words Morgan and Brian typed correctly in a typing test. For both students, the relationship between words typed correctly and the time is linear. So it's a linear equation. What that means to us is that it's going to make a straight line. It's going to be y equals mx form, maybe y equals mx plus b if it's non-proportional. And so what it wants to do is we got to find a couple different things here in this. First thing we've got to do is find Morgan's unit rate. So with the table, we're going to find the rate of change in x, which is our time, and change in y, which is our words. That means time is our input, and words is our output. All right, so let's go ahead and take a look at time. So we're increasing by 2 minutes. So for 2 minutes, our change in x, right? And then we're going to look at our change in y. So for every 2 minutes here, that's 30 words. 30 words here, 30 words here, 30 words here. So our change in y is 30. So we want to flip that, right? So m for Morgan is change in y over change in x. So we're finding that rate of change first, which is 30 words for 2 minutes, or in unit rate, 15 words per minute. And unit rate is like per 1 unit, guys. So you got to make sure that it's not 30 over 2, because that's the rate of change, but with a unit rate is the most simplified version of that. So it's comparing y to 1x here. So 15 words per minute for Morgan. Now we're going to find Brian's unit rate. So let's take a look at our graph here. So it starts at 0, and then I'm just going to travel along and find nice, clear intersection points. So here is 2 and looks like 40, 3, and 60, 4 and 80. So, and then if I look here at 1, that's always going to tell me my unit rate on a graph. So at 1 minute, I've got 20 words. So you can find the rate of change here by comparing, right? Or you can find for a unit rate, you're going to look at the value of 1x. So when x is 1, so 1 minute, you've got 20 words. So 1 minute, 20 words. So Brian's unit rate is 20 words per minute. Okay, so the next question then is, which student types more correct words per minute? Well, all we got to do is compare our unit rate here, right? So Morgan types 15 words per minute. Brian types 20 words per minute. Brian types a greater number of correct words per minute. And we know that these are values represent typed correctly because it told us that up here, typed correctly on a typing test. Brian types more correct words per minute, and because he has a greater unit rate. We know this because he has a greater unit rate. His unit rate is 20 words per minute, whereas Morgan's unit rate is 15 words per minute. And we know that 20 is greater. So let's go ahead and just reflect on this a little bit and think, okay, well, Katie types 17 words correct per minute. Explain how the graph of Katie's test results would compare to Morgan's and Brian's. So if her unit rate is 17, it's going to be less than Brian's, right? So it's going to fall somewhere, like her first would be 17 words per minute, so it would be below, be a little bit below. So hers would fall, below Brian's. But 17 is greater than 15 words per minute, which is where we would find Katie's, right? So hers, so this would be Morgan's, and this would be Katie's, and then this is Brian's. Because she has a unit rate that is greater than Morgan's, but less than Brian's. So if Brian's is 20 words per minute, Katie's is 17 words per minute, and Morgan's is 15 words per minute. So Brian's is greater than Katie's, Katie's is greater than Brian's. That's my greater than sign, right? So on the graph, her line would be greater than Morgan's, but less than Brian's. Oops, let's try and spell correctly. Would fall so her unit rate would fall between Brian's and Morgan's because Brian's unit rate is greater, but Morgan's unit rate is less. Okay, so again, we're just comparing two different representations of functions, and this is a function because the number of words is a function of time, meaning the number of words depends on the amount of time passed. Okay, so we're going to go ahead and do one more activity, but if you're feeling pretty good about being able to compare functions, you can go ahead and stop doing notes here. If you want to continue on, you are absolutely welcome to. We're going to do one more activity where we're comparing graph and descriptions. So if you're someone who struggles with pulling information from descriptions, I would go ahead and continue on, but this is optional from here. Since we're not introducing any new information, all we're doing is applying what we know to comparing functions. Okay? So continue on or go ahead and stop at this point. It's up to you. So this last scenario that we're going to look at is comparing graphs and descriptions. And what we've got is Jamal, who wants to buy a new game system that costs $200. So $200 is the total cost. He does not have enough money to buy it today, so he compares layaway plans at different stores. Now, if you don't know what a layaway plan is, that means that it's like a payment plan. So he doesn't pay it all at once. He pays it in small chunks over time. So this plan at store A is shown on the graph. Okay, so this is store A, right? But store B requires an initial payment of $60 and weekly payments of $20 until the balance is paid in full. So what we need to do is we need to write an equation in slope-intercept form for store A's layaway plan and let X represent the number of weeks and Y represent the balance owed. So X is our input is number of weeks, Y is our output, and that is the balance owed. So you'll notice on this graph for store A, which we're going to do in blue, it has an initial value of what? 100. Okay. So, and then it goes down by how much? So this one's kind of in the middle. It's kind of hard to read. So we're going to go to this one. And after 2 weeks, it's gone down. We're going to find our rate of change here, 20 over 2 weeks. So the rise and run, or change in Y over change in X, is down 20, 100 to 80. So that would be 20. And negative, because it's going down. And that's over 2 weeks, the period of 2 weeks. So if we simplify that, that would be $10 per week. So the payment plan, or the rate of change for this one, is $10 per week. So M, in this case, is 10. So he has to pay $10 per week with store A. But there's an initial cost, too. There's an initial value. So it's starting with 100, and this is confusing, right? Because the original cost isn't $100. The original cost is $200. This means that he had to pay $100 up front, right? So 200 minus 100 gives us 100. So that's the remaining balance that he has to pay off after an initial fee of $100, right? Sorry. And that's confusing because they're both 100. So the equation for this would be Y equals negative 10x plus 100, right? So it starts out at 100, but it's going down at $10 per week, and this is store A. So in store A, he had to have an initial payment of $100, which means he has $100 remaining, and he's paying it off at $10 per week. So that's what that breakdown is. So let's go ahead and take a look here at B. Write an equation in slope-intercept form for store B's layaway plan. So we've got the information here. It has an initial payment of $60 and the payment of $20 per week until it's paid in full. So in this case, we've got Y equals 20 negative 20x, right, because he's paying against it. He's paying it down, plus an initial fee of 60. So he had to pay 60 first, and then he has to pay off the rest at $20 a week. So sketch the graph of store B on the same grid to show an initial payment. Okay, so our gut tells us that we want to start here at 60, but that's actually going to be incorrect because that's what he's paying off of the initial cost of $200, right? So he starts with $200 is what the cost of the game system is. He pays 60 in his initial fee, and so he has $140 left to pay off, right? So that's where this is starting. So does that actually change our equation? It doesn't in this case, because what we have is we have $140 left to pay off.